Hello, this is mathjazz from Almost Cool, and this is another episode of my calculus live stream. I received um, no questions via email, so I don't have any of those, but I'm gonna try and watch chat while I'm doing this. Uh, Hello, Aiden Elmore, and I have a I have two problems that I've teched up ready to do on the live stream. And I guess I'll do those first. And if we have other questions coming in through chat or through email, then we'll handle those. This will be a shorter live stream. I'm going to say maybe 20 or 30 minutes, unless we get a lot of questions. So here we go. Here is problem one. We are going to find the area bounded by the following curves. They are x squared and x cubed. So the first thing that we're going to have to do, I have a graph here of this situation. Here, let me make it larger. The blue curve is x squared. The yellow-green curve is x cubed. And the blue shaded region is the region that we want. This area right in here. Oh, I guess my mouse is not being captured. Let me fix that. Okay, let's see. Is this working now? Okay, so I think the cursor will show up in a little bit. There it goes. Found it. Okay, so we want this light blue region here to be, we want to figure out the area of this region. Okay, so the first thing we're going to have to do, of course, is we're going to have to figure out where these curves cross each other. Otherwise, we can't get our limits of integration. I'm going to shrink this graph down again, and let's do what we need is to solve for all of the intersections between the curves. I'm going to just copy and paste solution when I need to. There we go. So, first thing we do is we set the two curves equal to each other. Oh. Sorry. The original problem I had was x squared and x cubed, but I decided that was boring. We'll do it as well, but let's do the one that I have written up first. So, this yellow curve is the graph of x cubed minus x, and the blue curve is the curve x squared minus 1. There we go. So first we set the two curves equal to each other. X squared minus 1 and x cubed minus x. We subtract one from the other to get this equation here. X cubed minus x squared minus x plus 1 equals 0. So here we have to figure out the roots of this polynomial. So solution, well, the first thing we notice is that on the first two terms we can factor out an x squared. These two terms we can factor out an x squared, and this term will factor out a negative 1, leaving us with x squared, x minus 1, minus x minus 1. And then we can from here, factor the x minus 1 out from each of these products and get x squared minus 1 times x minus 1 equals 0. And factoring this difference of squares, we get x plus 1 times x minus 1 squared. Now, there are probably a bunch of ways that we could go from our original polynomial to having a factored form, but this was the way that I did it. So, let's move that up the screen. So now that we've figured out our solutions, our intersections between our curves, I typed the same thing again. There we go. This means that the limits of integration should be 1 and negative 1, because the solution to this equation was 1 or negative 1. So those are our limits of integration. We set up the integral as so, or like so. If I can make that bigger. Anyway, so we integrate, we subtract the smaller of the two curves from the bigger of the two curves on the endpoints, or between the endpoints that we found. Remember, on the region that we're describing, the cubic has the larger y value than the quadratic does. So that's why we integrate the cubic minus the quadratic. Otherwise, we would get a negative area. So that's why we have this integral set up the way that we have it. After we take the antiderivative, we get this as our antiderivative, where we will plug in 1 and get a value, and we'll plug in negative 1 and get another value, and we'll subtract the second one from the first. So, doing that, I think we get 4/3. There we go. Yeah, here we plug in those values, and then after we plug in those values, we get 4/3 as our answer. So it's really not too bad. I mean, once we figured out what our integrand should be, that is the thing inside of the integral, and what our limits were, it was just the power rule. It wasn't so bad. The integral itself, the calculus itself, was not the bad part. The confusing part was figuring out what calculus to do. That is, what should our integral be? And that's very typical of first-year calculus classes, is that usually the hard part is the geometry and the algebra, not the calculus. So, that solves our first problem for us. Our answer is 4/3 is the area between the two curves. So we will clear all of this off and start over with a new problem. Problem 2. So we're going to find the area bounded by the following curves between x equals 0 and x equals 2 pi. Okay, so this is a graph. The blue curve is the sine curve, and the yellow-green curve is the cosine curve. And the shaded region is what we need to take the area of. Well, not the entire shaded region. From this x-axis over to 2 pi, which is about here. We want to find this area. Now, you notice that I've colored the region blue in some places and red in others. And the reason why is because the red region is area where sine is greater than cosine. And the blue region is region where cosine is bigger than sine. If we were to just integrate cosine minus sine, then the blue areas would be positive and the red would be negative, and we'd get cancellation. We'd have area canceling with area, and that's not what we want. What we want is for all of the areas to add up nicely in the usual way. We usually don't say that, for example, a farm has 5 positive acres and 3 negative acres. That wouldn't be make sense in the situation. However, um, we can measure these areas by breaking up our integral into 3 regions. The blue regions being regions where we're taking cosine minus sine and getting a positive number, and the red region being one where we're taking sine minus cosine to get a positive number. Okay, so with that in mind, we must solve for all of the intersections between these curves. Go. So we set one curve equal to the other, we get sine equals cosine. And we know that the only places where this occurs on our interval are at pi over 4 and 5 pi over 4. And just for confirmation, we look at the graph, we notice pi over 4 and 5 pi over 4. So now we take this pi over 4 and 5 pi over 4, and we break up our integral into 3 regions, and they are as follows. Oh, that's not what I want. There we go. We'll integrate cosine minus sine on the first interval, sine minus cosine on the second interval, and cosine minus sine on the third interval, so that we get a positive area in each region. So we'll integrate from, this should be 0 to 5 pi over 4. Sorry, pi over 4. Just delete that. Skip to 27. Oh, these slides aren't correct. Gotta check my slide for a second. Oh, this way. Here we go. That should be 24, that's 25. This is 26. this gets deleted. Okay. And now we're back on track. Here's our integral, our three integrals, that is. And so we have the first region is this one, cosine minus sine on the first region. We have sine minus cosine on the second region, and cosine minus sine on the third region. Now the integral, or the antiderivatives of each of these are easy. The integral of the indefinite integral of sine is going to be negative cosine plus c. The indefinite integral of cosine is sine plus c. We plug in the values and subtract appropriately, getting solution 26. Which is 4 times the square root of 2. Because we plug in all the values in the appropriate way, and it simplifies to that. So that 4 square root of 2 represents this area in blue, plus this area in red, plus this area in blue, up to, I think. And let's see, we have no questions in chat, and no email questions. So I guess we'll take up some time talking about channel news, just because this is an okay forum for that. It's been 4 or 5 months since I've done a live stream on calculus, and that's changing today. We're going to have weekly live streams at 6 o'clock. Well, 6 o'clock Mountain Standard Time. That's going to be 5 o'clock California time, or I guess 8 o'clock Eastern time. And we're going to do calculus problems, mostly integrals, I think. We did a lot of derivatives last time, and we'll do integrals, and maybe we'll get into some series. But if you have any questions, then please email them to me. I guess the last minute to submit them would be, of course, during the show, or in the chat, and I will answer them. I will answer your math questions. So have a great week. See you Monday at the next live stream, and bye.